Let's begin by talking about displacement. Displacement is different than saying position or distance. Displacement is actually the change in position. And what that means is if this football player were to start here, run to the opposing end zone and back, they would have gone a distance of 200 yards, but their displacement would be 0, because in all actuality, they didn't change position at all. Their x didn't change. And this matters because when we're talking about the difference between speed and velocity, it's because of displacement. So speed is just distance over time, whereas velocity is the change in displacement over a change in time. So that could also be written as the final position minus the initial position over the final time minus the initial time. And this in particular is actually average velocity. So this little line above the velocity symbol stands for average. So if we did an example problem, we could say that a person runs to the right 100 meters, so their final position was 100, they started at the origin, in 5 seconds. And their original time would be, of course, 0 seconds. So that gives us 100 over 5, and that gives us 20 meters per second. There's also instantaneous velocity, and that's described more in Chapter 2, Section 2.3, if you want to know more about that. And that just instantaneous velocity means at any given instance, how fast is that person or thing going, okay? And that's a lot of times important when we're talking about velocity when we're using calculus. We probably won't be using instantaneous velocity very often in this class. So now that we've kind of talked about velocity, let's talk about graphing. So if I have a graph that is time versus position, and it has a positive slope, this means that a person started at the origin, walked away from whatever sensor or whatever was detecting this motion at a constant rate, and ended further away. So they say this took them 10 seconds, and they went 10 meters. So they went 10 meters in 10 seconds. So their velocity, their average velocity, would be 10 meters minus 0 meters over 10 seconds minus 0 seconds. And that would be 1 meter per second. And if you kind of remember from algebra, that 1 meter per second is actually the slope of this line. So our m is 1. Our equation for this line would be y equals 1 meter per second x. So we could continue this graph on for a while, but there's kind of no sense to, because it's a pretty simple graph and the velocity or the slope is constant. So what does that mean for the other kind of graphs that we were working with? Well, if we were to make that same graph into a velocity, so that's meters per second, versus time graph in seconds, with the same exact shape, what does that mean? So take a second, think to yourself, what does this kind of graph really mean? So what this means is that if this person took 10 seconds to go 10 meters per second, they are increasing their speed or their velocity at a constant rate. So we could even find what's called the average acceleration. So similar equation to the position, or to using the position versus time graph to find velocity, we can use the velocity versus time graph to find the average acceleration. And this equation is just the final velocity minus the initial velocity over, same thing as before, the final time minus the initial time. And in this instance, our average velocity would be 10 meters per second minus 0 meters per second over 10 seconds minus 0 seconds. So if I kind of bring this up here, that would give us 10 meters per second over 10 seconds, which equals 1 meter per second, or 1 meter per second squared. And that's what you'll see most often, this kind of notation, the meter per second squared. Sometimes, just conceptually, it's easier to think about it as meters per second, because it's the rate at which the velocity is changing. So this person, if you look at the slope of this line, they're continually increasing their velocity at a constant rate of 1 meter per second. Okay, so the slope of this line is 1 meter per second squared. And that's what we got using this. In my other video, I talked about why it's important to use average velocity, because if you just decided that I live 8.8 miles away from Summit High School, and it takes me about 20 minutes, give or take, depending on the day. So to find my average velocity, I went 8.8 miles, and I started at my house, so 0 miles minus 0, and it took me 20 minutes, and when I started I was at 0 minutes. So I went 0.44 miles per minute, or if you do the conversion, is 26.4 miles per hour. So if you really kind of think about what this means, this is saying that my average velocity was 26.4 miles an hour, but I didn't go that speed the whole time I was driving. I left my house and was going 0 or 2 for a little while. I stopped at a lot of stop signs. I stopped at stoplights. I went around roundabouts. But when I was going up and over Aubrey Butte, I was able to go 40 miles an hour. So this is important to understand, that I wasn't necessarily going 26.4 miles an hour the entire drive. That is just my average for that trip. So that's kind of displacement, speed, velocity, and acceleration in a shortened version, and we'll talk about this stuff more in class.